So what about some tests? Let's write some tests. Now, for a lot of these more basic contracts, especially like this hour token, we can actually use AI to get jump started, right? And I want you guys to use AI to get jump started and use AI to help you learn. I don't want you to use it to substitute learning. Oh, and oh my goodness, I almost didn't do a named import. That would have been embarrassing. I want you guys to use AI to help you learn, not to substitute learning. Because if you substitute the learning with the AI, the 10% or the 5% of the time the AI gets it wrong, you're going to have no idea how to fix it. It's really important that you still learn all these concepts because AI is still going to get a lot of things wrong. But AI is usually pretty good at writing tests. So let's start writing some tests. And we're not going to write all of the tests. We're actually just going to write a couple, and then we're going to see if our AI can autocomplete it for us. So let's do our token test.t.sol. Let's make some really basic test stuff here. SPDX, you know the drill. Pragma, Solidity. Contract, our token test is test, which means we're going to need to import test from forge std / test capital.sol. Okay, we're going to need a function setup, which will be public. We're going to need our deployer here, like this. We're going to import deploy our token from // script / deploy our token.s.sol, like that. In our setup, we probably want our script to return our token, right? So we're going to say our token OT equals new our token, return OT, returns, return. Okay, cool. So now at the top, we're going to want to import our token as well from / src / our token.sol. At the top, we're going to want to do an our token public OT, our token. Now we're going to we'll make a deployer as well. Deploy our token public deployer. We're going to say our token, deployer equals new deploy our token. Our token equals deployer.run. Thanks, GitHub Copilot. And that's pretty much all we're going to need. But let's also make some addresses so that we can interact with people. So we'll make an address Bob equals make ADR Bob. And then address Alice equals make ADR Alice. So we have a Bob, we have an Alice. We'll have the two of them play around with deploying and working with tokens. The owner of our token should be the deployer. So let's do vm.prank address deployer. And then let's transfer some tokens to Bob to get started. So we'll say our token.transfer Bob. And then let's do a little UN256 public constant starting balance equals 100 ether. So we'll give Bob 100 ether. And we'll do a little test. We'll do function test Bob balance public assert equal starting balance. It's going to equal to our token dot balance of Bob. All right, let's test this. Test -m test Bob balance. Oops, forge test. Transfer amount exceeds balance. The actual owner's message, that's sender, not the deployer. Sorry. So now let's do this again. And hooray. Okay, that looks cool. Great. So that's one test. Let's write a couple more tests, and then let's try to see if AI can do it for us. So let's even just write like test allowances. So we'll say function test allow and says public. Now, something important about ERC20s is that they have this function called transfer from. And this is a really important function. We saw it a little bit in the last section, but if I want my contract to keep track of how many tokens it has from you, it needs to be the one to actually transfer the tokens from you to itself. In order for it to take the tokens from you, you need to allow it to do that, right? If we just allowed anybody to take tokens from anybody, that would be really bad. So these ERC20 tokens, if we go back to the standard, they have this thing called, in the transfer function, you can actually read about it here. The transfer from method is used to withdraw workflow, allowing contracts to transfer a token on your behalf. This can be used, for example, to allow a contract to transfer tokens on your behalf and or charge fees for sub-currencies. The function should throw an issue unless from has deliberately authorized the sender of the message via some mechanism. And this is this allowances thing. And you'll see on most UIs, on most applications, you need to approve the contract to pull your tokens first. And sites like etherscan.io have a beta tokens approval section where you can actually connect your contract, connect your address, connect, and you could see, let's switch to ETH mainnet, and you can see all the approvals that you have. I don't have any on ETH mainnet on this address, again, because this is my dummy address, but it's usually good practice to see what these approvals are and then revoke them, especially if you don't trust the contract. Because if you approve a contract to transfer from on whatever they want, then they could just steal all your money, right? It's a good idea if you're making your own token to make sure allowances work well. So we're gonna write a real quick test on this. So we'll say uint256 initial allowance. We're gonna say test allowance works. Terrible test name, but whatever. It's just a dummy. Test allowance equals, just say 1,000. All right. Now we're gonna say Alice approves Bob to spend tokens on her behalf. Let's close this. So we're gonna do vm.prank, or excuse me, Bob approves Alice spend tokens. So we'll say vm.prank Bob, and we're going to run our token.approve Alice initial allowance. And if we go to our token, if we could command click or control click into the ERC20 and we look up approve, there's this approve function, which has this inner function approve, where if we command click or control click on that, we update this allowances mapping. And if we go to our transfer from function in here, let's just look around for it. Here it is. We see that it calls this spend allowance function, which if we look at that one, it requires that the current allowance is greater than whatever amount that you're approving, whatever amount they're spending. So you have to explicitly approve other people to use your tokens. And you don't actually have to approve anything sometimes, right? You don't have to approve anybody to use your tokens. And that's probably the way you ideally want it. But sometimes you do if a contract wants to keep track of how many tokens that you've sent it, for example. So we're going to prank Bob. We're going to approve Alice to use our tokens. And what we can do then is we're going to vm.prank Alice. And now she is going to take our tokens from Bob because Bob approved her to do so. So now we're going to do our token dot transfer from, and we're pretending to be Alice here. Transfer from Bob. We're going to say from Bob to Alice. And then we're going to create some transfer amount. We'll do like uint256 transfer amount equals, let's do half of the allowance, that transfer amount. We have to do this transfer from function. If we were to do just transfer, if you do just transfer, whoever is calling this transfer function automatically gets set as the from. So if you call transfer, it automatically sets the from as whoever's calling. So that's the difference. So transfer automatically sets the from as whoever's sending the message. Transfer from, you can set anybody from, but it'll only go through if they are approved. That doesn't make sense? Ask questions in the GitHub repo. Now we can do a little assert equal. Our token dot balance of Alice is going to be that transfer amount, right? Because she took it from Bob. And then, and then assert equal. Our token dot balance of Bob is going to be that starting balance minus the transfer amount. Transfer, there we go. Let's spell this right. And let's run this test. Forge test-m, paste it in. You can tell that I've written forge test-m a billion times, and it does indeed pass. Okay, great. So if we do forge coverage, we're going to get, hey, you got barely anything covered. Yep, sure, we have barely anything covered. So I actually wrote, and we want to write some more tests for this. Now, tests are something that AI is actually very good at doing. And let's go ahead and actually practice sending ChatGPT or any AI a prompt to actually generate some tests for us. If you want, in the Foundry ERC20 F23, we've got a little prompt for you to work with if you want to just copy paste it. So I'm going to copy mine, bring it over here, paste it in, but I'll tell you what it says. It says, here's my Solidity ERC20 token. And we literally pasted in the token that we just created. And here are our first couple of tests written in Solidity. So we wrote those couple of tests in here. Can you write the rest of the tests? Please include tests for allowances, transfers, and anything else that might be important. And let's see what it gives us. And we get an output. It looks something like this. So we can go ahead and grab this and stick it in our test and see what happens. So I'm going to go ahead and copy it. And I'm going to paste it. And I'm going to highly recommend you don't just blindly copy paste code from ChatGPT. That is a very quick way to accidentally get wrecked if the AI gives you a bad answer. I've already read through this, so we're going to be good to go. But you'll notice it already did a couple of weird things to us. So it removed the import deploy our token from our deploy script. And so I have to add that back in. Setup looks okay. It also removed Bob and Alice. It did some other weird tests. So I'm actually going to not blindly copy paste it. I'm actually going to undo that copy paste. And what we're going to do is instead, we're going to be a little bit more intelligent with how we work with AI. So I'm just going to take the stuff that I want out of here. Test allowance. I like our test allowance. Test transfer. Okay, we'll grab that. Test balance after transfer. Okay, test transfer from. Sure, let's grab those and see if those are good tests. Test transfer, amount equals 100. It gives us a dummy receiver. rToken.transfer, receiver amount. Assert equals rToken.balance of receiver is going to be amount. That's a good test. Test balance after transfer. It's going to doing another transfer and testing our balance. Okay, so that's pretty good. And then test transfer from, it's doing some approve. It's doing an approve and a transfer from on itself. So that's like redundant. This isn't a great test, but whatever. Let's see how it did. Forge test. And we have some issues because of course we do. So we get test balance after transfer. This one fails. Why does this one fail? Let's do forge test-m. Do that specific test. We'll do with some -VVs in here. And we could see transfer amount exceeds balance. Why does this fail? Because we're not vm.pranking the message.sender. So we got to do that. vm.prank message.sender. And we're going to have to do that for everybody. Test transfer from vm.prank, vm.prank, although this is definitely redundant. Okay, no, that actually works. We'll VM prank the message sender. We'll prove address this, and we'll do that. That one looks good. This one's going to need a vm.prank. Okay, let's try this again. Forge test. A couple of these still failed. Test balance after transfer failed. It's because we're getting the address of this. We need to get the message.sender. So it should be the balance of message.sender instead. But you can see as I refactor this that AI can be helpful. It gave us the scaffolding to a lot of this, but we're still having to go back and redo some stuff. And this is why it's so important for us to actually understand what's going on. Still gets so much wrong. We got an insufficient allowance down here. So our token approving address this amount. Our token to transfer from address this to receiver. We would need to transfer from message.sender. And now that should be most of it. Forge test. And great, now all of our test passes, and they actually pass, and they're actually doing some coverage, right? It's not perfect. So if we run forge coverage, it's definitely not perfect. In fact, it barely did anything, but it did more tests for the ERC20. But we could go back to ChatGPT and say, hey, great job. Can you write some more tests? Give it some more prompts, etc. But you can see that at least it can be very helpful in getting you started, getting you going, write tests if you haven't before. And of course, if you want to actually deploy this to a real network, you would do what? You would put your .env, your .private key, or you use third web deploy or something, and you deploy to a network. So that's it for this lesson. I know this was a quick one. Congratulations. I know this one felt a lot quicker and easier than the last one because now we're getting more advanced. Now learning actually becomes easier now that we have a solid foundation beneath us. So take a break, get some coffee, get some ice cream, and I'll see you in the next one.